Hello, my name's Neil Havis and I'm going to be talking today about management of Ramularia leaf spot without chlorothalonil. So, the viewers of you don't know much about Ramularia, this is a new disease which has really become important in barley in the last 20 years. It followed on from an initial identification in 1998, and what it does, it produces symptoms in the crop late in the season which reduces the yield and quality, and we estimate that it causes economic losses of approximately £9.5 million on an annual basis to barley production in the UK. So the fungus produces symptoms on the leaves, produces spores, and also produces a toxin, and it's the toxin that causes the necrosis on the leaf surface and a loss of photosynthetic area. So there are a number of rules that we use to identify Ramularia and distinguish it from other diseases in barley. And we define these as the 5 R's. And the first R is there's a reddish coloration to the lesions. The lesions are always rectangular, which means they don't elongate up the length of the leaf. Around each lesion you'll see a ring of chlorosis, so a kind of yellow halo to the necrotic area. One thing we've noticed about Ramularia studying it is that the fungus never crosses the vein in a leaf, so when we see the symptoms they're always restricted by the leaf veins. So there's a nice tight edge to the lesion, and if you turn the leaf over you'll see exactly the same symptoms on the underside of the leaf. So the symptoms are right through, and that differentiates it from many other diseases. So the life cycle of the pathogen. We've been looking at Ramularia now for approximately 20 years. We've discovered that the fungus has a seed-borne stage, so it's actually contained within the seed. When that seed's sown, the fungus moves in the developing plant. As you follow the life cycle, you'll see the plant germinates, it tillers. Occasionally you can see some spots on dying leaves of winter barley crops. As the crop grows, the fungus is moving asymptomatically inside the plant. Eventually the plant reaches a heading stage and flowering, and it's after the flowering, around about growth stage 72 onwards, that we actually start to see the symptoms of Ramularia in the leaf. There's also a secondary spore structure that we find on straw and sometimes on leaf. This is a black structure. This could be overwintering, or it could be the site of recombination in the fungus, because we know the fungus is capable of developing rapid resistance to fungicides. The fungus also produces spores during the growing season, you can see in the life cycle. So the release of spores seems to be related to wetness in the crop. You get more spores released, and what we have seen is there's a buildup of spores and a peak towards late summer, rather than other diseases where you get different peaks or multiple peaks during a growing season. With Ramularia it builds towards a major peak late in the growing season. We've put on the fungicide intervention points. We used to see activity from T1 fungicides. We don't see that much anymore. Most of the control of Ramularia relies on the late season or T2 fungicide application. So there are a number of factors which can affect Ramularia severity in the growing season. One is sow date. Our studies have shown that there is a link between the amount of spores being produced in the environment and how early you sow a winter barley crop. So the possible green bridge effect, which has been discussed for some pathogens. So it's movement from one crop to the following crop. And there does seem to be a relationship. So if you're sowing a winter barley early, when spring crops are still in the field and there's potential movement of spores, this can affect Ramularia in the following growing season. Previous crop, obviously if you're growing barley after barley, we know the fungus, you saw the secondary spore structure. This can be in straw or in stubble, so we're looking at the transmission from this stubble or infected material into the following crop. This is another way in which the pathogen can move from one crop to another. There's anecdotal evidence where crops of barley in the southwest where they've been direct drilled and you have crop debris present, that Ramularia becomes more of a problem. cumulative temperature. So the temperature in the crop, or the temperature that the crop experiences, all influences the rate at which the crop senesces. The more rapid senescence, the more likely we are to see Ramularia symptoms. So we've seen in trials in the UK and also in other countries, if you get conditions which accelerate senescence, we see more rapid development of Ramularia. Rainfall in the summer. I said that the fungus grows asymptomatically in the plant. If there's lots of rainfall, this means there's plenty of moisture for the fungus to help it keep up with the plant growth, and also increases the likelihood of seeing symptoms later on in the growing season. Radiation intensity, so the toxin that the fungus produces is directly switched on by light. So the higher the light levels, the more intense the radiation. This can help produce more symptoms because it activates more toxin. The presence of other diseases, obviously the major disease we have on the left is Rhynchosporium. Once Rhynchosporium gets established in a crop, it can almost rob the crop of all the green leaf area. So you see less Ramularia because we've lost more to Rhynchosporium. Mildew and rust, these are two biotrophic pathogens. There's results from Germany suggest if conditions favour brown rust, they can also favour Ramularia. So the warm wet conditions that we've discussed previously, that can also encourage brown rust, but also be ideal for Ramularia. And when we see more mildew in the crop, we tend to see less green leaf area available for Ramularia to infect. One of the things we do from HDB is we monitor the efficacy of fungicides on an annual basis. So you can see these are results from 2019, the graph on the left. You can see the curve. So it shows you on the x-axis this is the percentage of full label dose of fungicide, the y-axis is the percentage of Ramularia. You can see the green line, which corresponds to Bravo, is the most effective in controlling and reducing Ramularia symptoms in the crop. There is a new azole produced by BASF called Revistar, and you can see that also has some good activity against Ramularia. The blue line you can see on that graph is Proline, prothioconazole. You can see it does have some activity in 2019, but is not up to the levels of the other two fungicides. We are worried about Ramularia because in 2017, the graph on the right, you can see a similar fungicide performance curve, and in 2017 we saw no activity from the azole or SDHI fungicides. The only fungicide which had any activity was the Bravo, which is the green dotted line. Hence the concern that when Bravo was removed from its approval status. So we've been looking at a number of alternatives to control Ramularia from existing chemistry last year. So you can see in this graph we're looking at Ramularia symptoms in winter barley. On the x-axis you can see the different fungicides that have been used, and you can see compared to the untreated on the left hand side, they've all given a reduction in Ramularia. We even see some activity from some of the other multisites, Fulpit and Laminator Flow. None of these fungicides give the same kind of level of control as Bravo, and you can see that on the graph. That trial was taken through to yield, so the blue line you can see on the graph is the actual yield response. So the other diseases were present. You can see all the fungicides used have given an increase in yield compared to the untreated on the left hand side. It's also given an improvement in 1000 grain weight, and some of them have given an improvement in specific weight as well. So in summary, Ramularia leaf spot's a major issue for barley production. The loss of the highly effective multi-site fungicide chlorothalonil has presented a challenge for farmers and growers, and will do. The short to medium answers may be using existing and potentially the new chemistry which is coming along, and the medium to long term answers will probably need some improved genetic resistance and new varieties to be introduced.